Morning everyone, today we're studying 9.4. This is solving polynomial equations in factored form. So factored form is going to look like when we were multiplying polynomials, like if we had x plus 5 and x plus 3 or something like that, that would be factored form. So we're going to start talking about this property called the zero product property. So it says, let a and b be real numbers. If a and b equals 0, then a equals 0 or b equals 0. So in this case, we could take this whole thing, either a is going to equal 0 or b is going to equal 0. So it says the zero product property is used to solve an equation when one side is 0 and the other side is a product of polynomial factors. So we would have x plus 3 and x plus 5 equals 0. That's when we use this property. The solutions of such an equation are called roots. They're also used to find the zeros of the function. So a zero of this function would be right here where it crosses the x-axis. Those are called zeros because they go through 0 on the x-axis, or 0 on the y-axis, I should say. We also have some over here. Now we're not going to graph these yet, but these are called parabolas. We'll get to them, but today we're just going to learn how to find the zeros of those functions, or how to find those points on a parabola. So if we take a look at this first one, we have x minus 4 times x plus 2 equals 0. So we're looking to solve this equation. So we said that either a or b has to equal 0, so one of these two things have to equal 0. So what we're going to do to find these zeros is I'm going to take x minus 4 equal to 0 and x plus 2 equal to 0. Now all I need to do to find these zeros is solve this equation for x. So I'm going to add 4 to both sides on here and get x equals 4. Here I'm going to subtract 2 from both sides and get x equals negative 2. So our zeros are x equals 4 and x equals negative 2. What that would look like on our graph is if I had 1, 2, 1, 2, 3, 4, I would have zeros I'm going to erase that and try that one again. That was really bad. So I would have zeros on 4 and zeros on negative 2, and I can make a parabola that goes through those. Now I'm not actually going to graph these, it's just showing you what it means. Here, m minus 3 times 4m plus 12 equals 0, so we're going to find the zeros of this function. M minus 3 equals 0, and 4m plus 12 equals 0. So here we're going to add 3 and get m equals 3. That's one of our zeros. Here we need to do a little bit more work. We're going to subtract 12. When we do that, we get 4m equals negative 12. Divide that by 4, and m equals a negative 3. So our graph of this equation would look like we would have a 0 on negative 3 and a 0 on positive 3, and our parabola would go through both of them. Last one, we'd have 3x plus 1 equals 0, and x plus 6 equals 0. So we have to subtract 1 from this side. 3x equals a negative 1. Here x equals a negative 1/3. Over here, if we subtract 6, x is going to equal a negative 6. Now both these are negative, that's fine. We would just need to have our parabola be on the negative side of our coordinate plane. Alright, now we're going to start factoring. So we're going to factor out the greatest common monomial factor. So we're taking out we're taking out 1, the greatest common 1 factor out of our polynomials here. So what we see here is that they've already multiplied this out for us. We have 4x squared minus 4x. So what we need to do is figure out what's on the outside of our boxes here. Now if we factor out the greatest common monomial factor, I'm looking for what's common between these. I see that they both have a 4, and I see that they both have an x. So this is the greatest common monomial factor. Now if we were trying to figure out what they multiplied by, I see that they have a 4. Now what I would multiply 4 by to get 4 would be 1. And then they already have an x, but here I see x squared, so they must have had to have another x. Here they already have 4, so they must have multiplied by negative 1. And the x is already there from the 4x, so it must be 1x minus 1. How we would write this then would be 4x times 1x minus 1. Here, if we were going to factor this out, I see a 6 and a 9. I see the greatest common thing between those two would be a 3. I see an x in the first one, but no x in the second one. But I do see a y in both of them. So I'm going to take y out of both of our terms here. So now what do I multiply 3 by to get to 6? Well, I multiply it by 2. This one, 3y doesn't have any x's, so the x cubed must come with that one. And the y is already with 3y, so this is all alone. This is all done. 2x cubed. 3 by 3 to get to 9. And we need one more y because there's 2 y's on this one. So we have 3y equals 2x cubed plus 3y. Here, if we take a look at this one's got a 3 box. So I see negative 3, 15, and 6. I see that I can take 3 out of all of those. And each of them have at least one p, so I'm going to take a p out as well. So 3 to negative 3, I know I need a negative 1. And then there's p to the 4th. I only have one p and 3p, so it has to be p to the 3rd power. 3 times 5 will give me 15. I need another p as well. And then 3 times 2. Now I already have the p and the 3p, so it's just 2 up there. So 3p times negative 1p cubed plus 5p plus 2. Alright, I want you guys to solve that last one. See what you can take out of everything, all the terms on there. Alright, now it says solve the equation by factoring. So it looks like we already have this equals 0. We've talked about how to do that. But first, we need to factor out what we can. So I'm just going to draw a box around these because it looks like they're already multiplied together for me. And what can I take out of both 15y and negative 50y squared? Well, I can take 5y out of both. I know 5 times 3 gives me 15. And I already have my y, so that's enough. Now 5 times negative 10 would give me negative 50. And then it has to have an extra y because it's y squared. So we would have 5y not equals times 3 minus 10y equals 0. Now we solve it. So we're going to set both of these two terms, or both of these two problems equal to 0. So I'm going to have 5y equals 0 and 3 minus 10y equals 0. Well, if I divide by 5 here, y is going to equal 0, so that's going to be one of my zeros. Here I've got to do a little bit more, so we're going to subtract 3. So we get negative 10y equals a negative 3. If I divide by negative 10, y is going to equal a positive 3 over 10 this time. So our zeros are 0 and 3 over 10. Now in this next problem, we have to solve the equation, but when we're solving the equation, we want something to equal 0. So what we need to do is we need to move the negative 25r over to the other side so we can have 0 on this one side here. So I'm going to add 25r to both sides. So we get negative 30r squared plus 25r equals 0. Now I'm going to factor this out. Now what goes into both negative 30 and 25? Well, I know that's a 5. And it looks like I can take an r out of both of those. So we have 5r. Now to get to negative 30, I'd have to multiply by negative 6. Now it's r squared, so I'd need another r. And to get to 25, I would have to multiply by 5. And I already have the r, so I can just leave it like that. So we would have 5r times negative 6r plus 5 equals 0. Which then would give us 5r equals 0 and negative 6r plus 5 equals 0. So here if we divide by 5, our r is going to be 0. Here we need to subtract 5. Get negative 6r equals a negative 5. Divide by negative 6. And we get r equals a positive 5 over 6. So our zeros are 0 and 5 over 6. Alright, so if we try a word problem here, it says a display in your school library has on top 2 rectangular tables arranged in an L shape, as shown. The tabletops have the same area. An equation that relates the areas of the tabletops. Well, I'm going to start with this first tabletop that I see. And I know that area is base times height. I look at base times height, the area of this blue one would be W times, now I see 2 feet as the extra, and then W on the inside, so W plus 2, and then that equals the other table, which is the same in area. This one is W times, well, we know that this side also has to be W if this side is W. So this one has to be W, or not W, but 10 minus W. So here's our equation. Now B says find the value of 1W. So what we need to do is multiply these out. W times W is going to be W squared. W times 2 is 2W. Over here we have W times 10, which is 10W. And W times negative W, which is negative W squared. So to solve for 1W, we need to get everything on one side. So we can set these equal to 0. So I'm going to add W squared to W squared and get 2W squared. Then subtract 10W. So it'll give me a negative 8W. And that's going to equal 0 because we got rid of everything over here. Now if I were to factor this out, I could take 2W out of both. So I would get 2W times 1W minus 4 equals 0. So it would be 2W equals 0. And 1W minus 4 equals 0. I divide that by 2. W equals 0, which doesn't make sense to have a length of 0. So if I go over here and add 4, I get W equals 4. Now that makes sense to have a length. So the value of W here is 4. So what's the combined area of the tabletops? Well, we just need to put that back into our equation. So if we look at our W squared, it would be 4 squared plus 2W. Well, we just actually need to put it into, well, we can solve this here. So 2 times, or 4 squared times 4 plus 2, so it would be 16 times 6. 16 times 6 then gives us 96. And then we have 2 of the same tabletop, so 96 times 2 gives us 192. Alright, we got to talk about vertical motion. So vertical motion is, a projectile is an object that is propelled into the air, but has no power to keep itself in the air. A thrown ball is a projectile, but an airplane is not. The height of the projectile can be described by the vertical motion model. So a ball is going to be thrown, and it's going to come back down because after it's thrown, it has no way of keeping itself in the air. A plane would lift off, and it has engines that would keep itself going. So it says the height h in feet of a projectile can be modeled by h equals negative 16t squared plus vt plus s, where t is the time the object has been in the air, v is the initial vertical velocity, and s is the initial height. So the initial height, s, is always 0 unless otherwise indicated. So it'd basically be it's starting from the ground. So if we take a look at this first one, it says a diver jumps from a diving board that is 24 feet above the water. The height of the diver is given by h equals negative 16 times t minus 1.5 times t plus 1. So they've already factored this out for us. It says where h, the height h is measured in feet and the t is measured in seconds. When will the diver hit the water? Well, the height, we said back here, that's where it's basically 0. So where is it on, where is it going to hit the ground again? Now the ground this time is the water. So we're looking for the t. So if we were to set this all equal to 0, we'd have to set everything here equal to 0 so we can solve this problem. So we would have negative 16 equals 0, t minus 1.5 equals 0, and t plus 1 equals 0. So we know that negative 16 does not equal 0, so that doesn't make sense. Here, if we added 1.5 to both sides, t would equal 1.5. And here, if we subtracted 1, t equals a negative 1. So we're looking for t here. Well, t is the time, so it would be 1.5 seconds. This is negative 1 seconds. Now negative 1 seconds doesn't make sense, so we know that it takes him 1.5 seconds to hit the ground after jumping off the diving board. Last problem, it says a startled armadillo jumps straight into the air with an initial vertical velocity of 14 feet per second. After how many seconds does it land on the ground? Well, we need to figure out first, what is the initial height? We know that s is the initial height. Now, we know that s is always going to be 0 unless it says otherwise. But this time it doesn't say otherwise, so it's still going to be 0. The height is where it comes back and hits the ground. So the ground still is 0. So if we write this again, we'd have 0 equals negative 16 t squared. So we're looking for seconds, so we're looking for time, plus v, which is our velocity of 14t, and that equals 0, but we don't need to write that because it equals 0, or plus 0. So if we factor this out, well, I know that between 16 and 14, I can put a 2 in there. I also can take out a t from both of them. So if I take 2 away from negative 16, I get negative 8. And then I know I need another t. Here I got 7t. And both of those equal 0. Not t, 7t, because we already have the t with the 2. So we would have 2t times negative 8t plus 7. So we have to solve both of these to equal 0. So 2t equals 0, and negative 8t plus 7 equals 0. If I divide this by 2, t equals 0, subtract 7 here, negative 8t equals negative 7, divide by negative 8, and t equals a positive 7/8. Now we're looking for seconds. How much seconds does it take to land on the ground? Well, it doesn't make sense to have them take 0 seconds to land on the ground. So this is a quick jumper, but